Hello, and in this part we're going to create procedural buildings that have been destroyed. So to start off, maybe also let's clean up quickly here our previous networks. So I'm going to place a frame here for the pad part, so where I create the pads, and then here I'm going to create a frame where I've created here the bridges. So there is a bit more structure here. Now I'm going to create another subnetwork here again, and this will then be for the buildings. So again here I want to input my terrain. This will be my first input. Then I would like to have a box that will be representing a house. So let's say on this area here or somewhere else, I would like to have a house that's like something like this in size. I think this is already the big house. So let's place it down here. It doesn't have to be perfectly on the surface. It can fly a bit. We will solve that then in the network. And what is also important here, I can basically rotate it like this. Maybe this is too extreme, but maybe some rotation could be nice like this. So this is my second input, and let's go in this network. So I'm going to first start out here with my second input, which was that box. And I want to start creating the basics for then making a house for this. So here again, I'm going to use the flat and dissolve edges. So if I input a cube from Unreal, it's a clean cube. Then I'm going to use for each connected piece. In case you have multiple houses, we are going to loop over each individual cube. So let's create that down here so we have enough space then to work with. So first thing to handle is how can I get actually my cube into a normal rotation. So right now I added some random rotation in it, so because that is possible. So if I now take the building generator from the lab tools and plug in that box, you see that it might not give the result that you want. So what I'm gonna do first is I'm gonna center the box again so it's nicely on the grid, and then put it back to its original position. So for that to work with, I'm gonna use a group, and in the group nodes I want to select the top primitive. So I'm gonna give this a name top primitive, and I want to use the binormal function here. Set this to 0 and the up vector to 1. Lower the slider until we have here this. Then another tool in the lab tools that is useful for this is the one called straighten. So this will then automatically, as you can see, it will try to straighten the mesh, but it's useful here to actually give a up group. So I just created the up group, and now it is actually nicely aligned. So we went from this shape to a nice aligned shape. Now, important here is we can actually output an attribute called X transform. So I use this as output, and then I'm going to use the X as align and align this cube here nicely into the center of my world. So now if I plug in the building generator, we will have a nice clean result. I might also increase the floor height to 3.5 or higher, because often I think with 3.5 or 4 are better heights or scaling. So now I have my building, but how do I actually get it back to here, its original position? So for that, I'm going to use the node called match size. So place down this node. And at the top here, you will find an option restore transformation. And when I click this, I can restore the transformation based on an attribute called X transform. So in here in the straighten, I outputted a X transform, and I want to restore it back based on that attribute. Now, one problem here is, since I generate a building here, the output X transform is actually gone. So I will have to transfer that value from this node back into this node. So there are a few ways we can do this, but let's use here our attribute transfer. So here, my building is the input, and my second input will be the straighten node. Now, closer look at where actually the X transform is saved. This is saved in the detail attribute. So in the transfer node, we're gonna have to disable the other ones and focus on the detail one. So we want to make sure we are transferring the X form value. So once that is done, you can see we have now the correct rotation. So that's the original rotation that we have. Now I will copy another match by size, and I will not be using here the restore transform. Now connect this to here. So by default, it will sort of do some alignment, or you can also scale this if you want to. What I'm interested in is using the second input, and I want to use basically my beginning shape. So let's maybe move this over here. So my input shape will then be here. And as you could see, it then snaps to that position. So this is my original shape, my original input. This is then the result. So I've made a simple system that can then detect a transformation, align it, make a building from this, and then throw it back at its original position and rotation. So that's already the first step of creating this building generator. Now I have my building here, and I would like to make it actually more interesting. So one way we can make it more interesting, right now it's a basic cube shape as well, but I would like to have some more structure in here as well, so it's not really a full cube. So after this axis align, I'm going to create a system that sort of gives a more random shape instead of a perfect square. So let's start out with the split node. So split normals. And I want to select the bottom primitive. So -1. Then I'm going to reverse this. So it's facing back up. Then add a subdivision, or you can use something else if you wanted, like a remeshing or quad meshing. I'm going to set the subdivision to 2. So we will create all these squares. Then I want to use a group range. And with this group range, I can now sort of procedurally select a few primitives, and these will then be my house. So I can do multiple variations. Either the primitives that are now highlighted are my building, or you can do the reverse, like the shape that is not being highlighted is my building. So two ways to, so you can choose between that. But what I also like to do is our sort nodes. And in the sort nodes, we actually have a primitive sorting, and we can set this to random. So now it's sort of a more random selection. So you can get more random in there. Then let's use a blast node and blast away that group 1. Then after that, I'm going to use an extrude node. And what I will do with this extrude node is give this a little inset. I'm also disabling here, disable the sides. Now the reason why I give an inset is because of here this region, like these two primitives are still connected to each other, and that often doesn't give that nice result actually. So I decided to do a little inset there. So now I have the basic shape that I want, and I would like to do an extrusion to then get the height back. So I want to then extrude based on the height that I actually had from this part. So from here. So maybe also place a null node here. And this was sort of like my base aligned. And now in here, I can use a spare input in this extrusion, add spare input. So at the bottom here, there is a spare input, and I can drag here my null node. And now in the distance, I can now add the bounding box. And I'm going to say, get the bounding box from -1, which is that spare input. And then I'm going to add the size in the y-axis. And then we sort of have the correct height as it was before. So now plugging this into my building generator will make it even more interesting now. As you can see, this is now my building. So this is more interesting. Now I can still play around here with the seed value. Like you can get quickly some random variations. You can also use the, for example, delete small parts. And in here, what we can do is we can, for example, extract the largest chunk. So we only have this as a result. So right now I want to then assign a modular model to actually my building generator. So what we will do is we will load in a model, like for example this model, or you can use your own models. I just have some pre-made models to use for the moment. Then we're going to use the utility tool. So this will basically assign a model name and a dimension. So the model name will be wall for the bottom, for example. And something special here we can also do is we can say multiply by a. This will make sense also later, because what we will do is we will create a second wall, because I will have more modular models, and I will then say b. So this will then be the variation on this. So the tool can then automatically pick some variations. Then also important here is to set the dimensions. You can open the spreadsheet here and double check the dimensions. So what I know is in my case, it's 1.5 in the height and it is 1 in the z-axis. So my dimensions will be 1 width and 1.5 in the height. So now that is set up, and let's plug it in over here with the building modules. And now we can open here our primary setting, and then we have to fill in here a model name. So we fill in here the name. So I'm going to just copy this and I'm going to paste it over here. And as you can see, it now is using that specific model. So now I have actually a variation called B. And what I did here is I just simply deleted that window. So we have then a version without the window. So now we will have, as you can see, automatically it chooses between a window and no window. So based on this, so it automatically do that for you. What's also interesting here in this generator is we can use the scale modules. So for example, here we had some new geometry created. But if you don't want that, we can then scale these models to the whole site. So based on what you prefer, you can then scale them or use the new generated geometry. So this is the basic idea of how you're going to add these modules to our buildings. I have more modular models, and I will then place them on the building here as well. So I will skip a few parts here and there. If you are interested in more information about this building generator, there is a lot of documentation and a test scene for you on the SideFX website. So here I loaded all my modular models and I assigned them. So here I have a bunch of them, and as you can see, like the example I did here with this, is we just assign a name and a dimension. So this is just all we do, name and dimension. What I also did here is I added a concrete group. This will later be useful when I assign the materials. So the materials will mainly be bricks and concrete. So I'm already assigning here a concrete group. And I'm actually converting that into a attribute. So this is my basic building. And I mentioned before, on the SideFX website, we have a whole documentation about this if you want to have more information. If you want to see general overview here. So I filled in here my settings for my wall, my corners, an edge. I disabled the bottom ledge. Then I have a custom override, which is basically here at the bottom. I have a unique model there, or a new model. And I can also set a different height here at the bottom. As you can see, I can make this way larger than the other ones. So in here I have a specific wall for the bottom, and again here setting the ledge, and I don't have a bottom ledge. So that's the main thing that I did here. Then next up, I actually want to restore back that concrete group. So I'm going to place a group node. And in here, I'm going to call that attribute. So I had the attribute called concrete. And if that it's equal to 1. So as you can see, everything that has that attribute is now being selected. So if you have your own meshes, you will have to assign these by yourself. Then further here, I'm going to do a blast node, and I will be blasting away that top geometry. I don't think that we need that here. So we can go here to floors, click on floors, and we can basically reverse this. So we have now deleted that top part. Then I'm going to use the split node, and I want to split based on the generated slop. So these are basically new generated planes, but I don't want planes. I would like to have solid surfaces. So I'm going to extrude this shape. So later I don't have a conflict with that. So let's extrude this. Probably going to extrude it by 2. Let's see if that is enough. And merge this back here. So let's disable the scaling here. So what I want is that the extrusion nicely comes together here in my surface, so I can see a little tiny line. So maybe let's add a little bit more. So now if you decided to not scale the pieces, we still have a nice wall without too many things going on there. Also important here can be double checking our UVs. So these are the UVs. These are very clean and nicely laid out, but they might be wrong in size. So you can always use a UV transform. So this is my brick texture. This is also again from Quixel library. And I can see there is a big difference between these generated planes and my actual modular models. So what I did for my modular models is the beginning of my modular model and the end would be able to tile nicely to each other. But here for these new generated pieces, I might have to lower some of the scaling. So after playing around with some of the scaling, I find the right fit here. So it fits a bit better with the other walls as well. So it is not that noticeable. There would just be a new geometry. Then next up, I'm going to use a divide node. So this will basically triangulate the mesh. And I'm going to enable don't generate silvers and small angles. Then we can use another divide node if you want that. And in here, we can use the breaker polygon feature. So as you can see, it will generate extra lines based on this grid. So that could just help later on with a few things. So when I do Boolean, this might help a bit with the construction. And also, I can use this extra geometry for vertex printing. Now then, let's start with adding some destruction. So I want to break some parts off the top of the building. So I want to generate some spheres and different shapes to then Boolean from this building. So to start with, I'm going to go back to my building generator. And I thought it would be interesting to copy paste this blast over here. And I want to start from actually the reverse. I want to start from this geometry. And I can use the split by normals. So here, and we can get, for example, the bottom part. This can then be resampled. So we create a lot of points there. So probably we'll go with something around 1 or 2. Like this, we can click this option to respect more the shape that I was inputting. Then we could do a random range. So we're going to select a few points there. So a few points like this. Then point jitter, because it's a flat surface now. Then we can copy paste a sphere. So copy 2 points, we can take a sphere, set the sphere to a polygon type. We can increase the poly count and multiply a mountain node. So this will create some more interesting shapes. You can play around with some of the noises more to get some certain shapes. So now I have this result. So these are all copied on the points, but I have this group range that's selected a few points. So I have a few of them. I can always do an exclamation mark if I want to reverse that selection. They maybe need to be bigger. So let's make them bigger. And we want to add some more randomness. So let's use the random attribute here. We're going to do a random p-scaling. And you can see that already works. But let's say the minimum value is 1 and the maximum value is 5. Maybe 5 is too much. Let's go with 3 then. That's better, I think. Then we can copy paste this random, and we want to have some random rotation. So we're going to use the normal. And now we have some more random rotations going on. I think this shape over here might be too much like a sphere. So I'm going to play around with the noise. I think this is a bit better. Before it was too much like spheres with some noise. Now it's a bit much better. Now after this result, I'm going to use a voxel. So this is just to avoid conflicts later on. So the voxel will create one big mesh out of this. So it will also change the topology. And voxel actually doesn't need to be a super high resolution. So let's set this to low. So it's a quite low resolution. And we can now boolean this from our building. So that might have taken a moment. So this is the result. We have now booleaned these shapes in there. Notice that we have some small pieces here. What we can do to clean up is we're going to place a fuse node. And I'm going to increase the fuse value. And then I'm going to use the delete small parts. So all parts that are too small, we want them just to be deleted. Like in this case, already this value works pretty well. What I also noticed here is I actually forgot something here. Is in our extrusion here, we actually have to enable output back. This will give a much cleaner result here. And as you can see here now, it's a better result. It's really a solid wall instead of that just plain geometry.